Hi everyone, welcome to the Simple Spark YouTube channel. Today we are diving into the fascinating world of the light, that is part 2, spherical mirrors. So the spherical mirrors are curved mirror that form images in amazing ways. So let's get started. Spherical mirror is a mirror that is a part of sphere. It has curved reflecting surface unlike a flat mirror which has a straight surface. This curved shape allows spherical mirrors to reflect light in unique ways. These mirrors obey the law of reflection and are commonly used in daily life, from vehicle mirrors to telescope. So there are two main types of the spherical mirror: concave mirrors, which are curve inward like the inside of the bowl, and convex mirror, which curve outward like the back of a spoon. So even though the surface is curved, these mirrors still follow the laws of the reflection. That is, the angle at which light hits the mirror is equal to the angle at which it bounces off. That is, the angle of incidence is equal to the angle of reflection. So when we consider the types of the spherical mirrors, the concave mirror is the mirror the inner surface reflect light. This mirror has a surface that curves inward inside of a bowl. Because it reflects light rays inward, it's also called as the converging mirror. We will find concave mirrors in things like makeup mirrors and dentist mirrors, where they help focus light and produce magnified images. Next is convex mirror. This mirror curves outward like the back of the spoon. It reflects light rays outward, so it's known as diverging mirror. Convex mirrors are commonly used as rear wave mirrors on vehicles and in security mirrors because they give wider field of view. So the rear view mirrors are used in security mirror because they give wider field of view. Next, let us see what are the key terms in spherical mirrors. Consider the diagram. The first is the concave mirror and the second one is the convex mirror. The key terms are same for both the mirror. First is the pole. So it is represented by the letter P. This is the center point of the mirror's curved surface. So the pole is the center of the mirror. So next is the center of the curvature and it is represented by C. The center of the curvature is the center of the sphere of which the mirror is just a part. Think of it as the original center of the full spherical shape. The radius of curvature, it is represented by the letter R. It's the distance between the pole and the center of the curvature. So the radius curvature is the distance between the pole and the center of curvature. Next is the principal axis. So the principal axis is an imaginary straight line passing through both the pole and the center of the curvature. So the principal axis is the imaginary line that is passing through the center of curvature and the pole. Next is the principal focus. It is represented by capital letter F. It is a very important point. For a concave mirror, it is the point where rays of the rays of light parallel to the principal axis meet after reflection. For a convex mirror, it is a point from which such rays appear to diverge. So the focus is the point for the concave mirror where the rays of light parallel to the principal axis meet after reflection. For the convex mirror, it is a point from which such rays appear to diverge. Next is focal length. It is represented by the small letter f. It is a distance between the pole and the principal focus. So the focal length is the distance between the principal focus and the pole. This length is related to the radius of the curvature by simple formula. The formula is focal length, the small letter f, is equal to radius of curvature divided by 2. So f is equal to r by 2, or r is equal to 2f. It is the relation between the focal length and the radius of curvature. Now let us understand some of the basic rules for drawing the ray diagram for concave mirror. The concave mirror is also known as the converging mirror. The first rule is any ray of the light that travel parallel to the principal axis after reflecting from the mirror will pass through the principal focus. See the image here. The concave mirror is there, and the principal axis is there, center of curvature is there, and also the focus and pole is there. The first rule says that whenever the light parallel to the principal axis, so the principal axis is already there. When the light is parallel to the principal axis, after reflection it passes through the principal focus. So the parallel lines after hitting the reflecting surface, it passes through the principal focus. That is the first rule. And the second rule is the ray of the light passing through focus after reflection goes parallel to the principal axis. So you can see there are some similarity between rule number 1 and 2. In rule number 1, the ray of light parallel to the principal axis after hitting the reflecting surface, it will be passes through the focus. But in rule 2, if a ray of light passes through the principal focus, after reflection it will travel parallel to the principal axis. And the third rule, when the ray of the light hits the mirror at the center of the mirror surface, it reflects off such that the angle of the incidence will be angle of the reflection. Fourth rule says that the ray of the light that passes through the center of curvature, the ray of light that passes through the center of the curvature of the mirror will be reflected back along the same path. In the image, you can clearly see that when the ray that passes through the center of the curvature after hitting the reflecting surface, it again passes in the same path. So these are the rules. So these rules help us understand how light behaves when it hits different parts of the mirror and are essentially for accurately drawing ray diagrams. So in the first rule, a ray traveling parallel to the principal axis after reflection passes through the focus. And the rule 2 is a ray of the light passing through focus after reflection goes parallel to the principal axis. And the rule number 3 is a ray of the light reflects off center of mirror, that is pole, with an angle of reflection equal to angle of incidence. And the fourth rule is a ray of light passing through the center of the curvature is reflected back along the same path. So next let us find the rule for the convex mirror, that is the diverging mirror. So the rule number 1, a ray of the light traveling parallel to the principal axis after reflection appears to be coming from its focus. So the rule will be same, but here the difference is in the convex mirror, the reflecting surface is curved outward. So the focus is on the other side of the mirror, that is the back side of the mirror. So whenever the ray of the light traveling parallel to the principal axis after reflection appears to be coming from the focus of the convex mirror, so observe the image. Although the rays don't actually meet, they seem to diverge from the point. So actually the rays are not made, but it is appears to be coming from or diverge from that point. And the rule number 2, a ray of light heading towards the focus of a convex mirror is reflected such that it becomes parallel to the principal axis of the reflection. See, the ray of the light that is going towards the focus of the convex mirror, it becomes parallel to the principal axis of the reflection. So third one is a ray of light heading straight for the mirror center is reflected back at an equal angle. So this is similar like the convex mirror. So the ray of the light incident at P, after reflection it is reflected back at an equal angle. So the angle of incidence will be equal to the angle of reflection. And the fourth rule, a ray of light heading towards the center of curvature is reflected back along the same path. So when the ray of the light is going towards the center of curvature, that is behind the mirror, it appears to be reflected back from the same path. So these rules help us understand how light behaves when reflected by a convex mirror, which always forms virtual diminished images. So now let us discuss what kind of images are formed depending on the position of the object relative to the mirror. So there are total 6 cases in concave mirror and 2 cases for the convex mirror. First, the case 1 of the concave mirror. The object is at infinity. When the object is placed at infinity, what will happen? So we can use the rule 1. We know that there are 4 rules. So for the image formation by the concave mirror, we can use any 2 rules so that we can find the position of the image of the object. So when the object is very far away, that is at infinity, the rays hitting the mirror are almost parallel. So we know that whenever the parallel lines that is hitting to the mirror, it will passes to the focus. So what happens here, we can use the rule 1 so that these rays reflect and meet at the focus. So when the object is placed at infinity, the image will be formed at the focus after reflection. So what are the characteristics of the image formed? So the position of the image is at F, that is focus, and the nature is real and inverted. Real image means we can capture the image in the screen, so we can capture the image on the screen. And inverted image means it is not straight image, it is inverted, upside down. So what about the size? Highly diminished. So the highly diminished means it is very very small, so very small image is formed. So whenever the object is placed at infinity, the position of the image will be at focus and it is real and inverted, highly diminished. So the second case is when the object is beyond the center of the curvature, that is beyond C. So here the AB is the object and that is placed beyond the center of the curvature, that is C. So we can use any 2 rules. So here first and second rules are used, that is when the ray of the light is parallel to the principal axis, and other rule is when the ray of the light passes through the focus. So when the ray of the light is parallel to the principal axis, after reflection it passes through the focus, and when the ray of the light is going through focus, after reflection it will be parallel to the principal axis. So the both rays after reflection is meeting at the point. So that point is the image formation. So the image formation, that is A dash B dash. So what is the position? When the object is beyond C, the position of the image will be between focus and center of curvature, that is between F and C. What about the size? Size is diminished, that is smaller than the object. And what about the nature? The nature is real and inverted. Real means it can be captured on the screen and inverted means upside down. And the third case is object at C, that is center of the curvature. So see, when the object is at C, that is center of curvature, how what is the nature of the image? We can see when object is at the center of curvature, here we use two rules, that is the ray of the light parallel to the principal axis. After reflection it passes through the focus, and whenever the ray of the light passes through the focus, it is parallel to the principal axis. So the image is formed at C, that is center of curvature. So the characteristics of image formed is the position of the image is at C, nature is real and inverted, size is same as that of the object. So whenever the object is placed at center of curvature, the image also formed at center of the curvature, and it is real and inverted, and it is the same as that of the object. The size will be same. And the next case is when object is between F and C. So when object is between the center of curvature and F, how the image forms? So here also two rules are used. So what happens? The image will be formed beyond C. So the image forms beyond C. So the image forms beyond C. So you can see the position of the object is between C and F, and position of the image is beyond C, and nature is real and inverted, and the size is enlarged. So it is, the size is greater than the object. And the next case is when object is placed at F, that is principal focus. So when the object is at principal focus, how the image forms? The reflected rays become parallel and don't meet. So we can say here two rules are used. The one rule is when the ray of the light is parallel to the principal axis, it passes through the focus, and the other rule is used is when the ray of light is passes through the center of the curvature, it passes along the same path. So it passes the same path. So here what happens? After reflection they will not meet, they will parallel rays that goes to infinity, the parallel rays to infinity. So the reflected rays become parallel and don't meet. So the image characteristics are, they are formed at infinity, highly enlarged, no clear image on the screen. So the position is at infinity, it is real and inverted, and it is highly enlarged. So no clear image we can see on the screen. So the next case is the object is placed between pole and principal focus. If the object is placed between pole and principal focus, so by using NA2 rules, the reflected rays diverge, so they appear to come from a point behind the mirror. So here what happens? So we are using the two rules, that is when a ray of the light is passes through the center of the curvature, it again passes the same path. So whenever the light travels to center of the curvature, it travels the same path. And another rule is the third rule, that is the when a ray of the light hits the center of the pole, it follows the laws of the reflection, that angle of incidence will be angle of reflection. Angle of reflection, angle of incidence is equal to angle of reflection. So what happens here? Both the line will be appears to be meet at one point, that is behind the mirror. So the image will be formed beyond the mirror. So the characteristics are, position is behind the mirror, the nature is virtual and erect. So you can observe in all these 6 cases, the first 5 cases the images are real and inverted, and in the last case it is virtual and erect. So the erect means a straight image, virtual means we cannot capture it on the screen. The size is enlarged. So these are the 6 rules. So we can see as together the object position, image position, nature. So when object is at infinity, the image will be formed at focus, it is real, inverted, highly diminished. When object is beyond C, the image position is between F and C, real inverted diminished, and if it is at C, image position is at C, real inverted same size, and between C and F, the image will be formed beyond C, it is real inverted and magnified. Magnified means enlarged. And if the object is at F, the image position is at infinity, and the nature will be real inverted and highly magnified, that means highly enlarged. If the object is between F and P, the image will be formed behind the mirror and is virtual, erect and magnified. So out of these 6 cases, we can see in the last case, that is when object is between F and P, it will be forms the image behind the mirror, that is virtual and erect. So next is about the diverging mirror, that is convex mirror. So when the object is placed at infinity, what happens? When object is very far away, that is infinity, the rays coming from it are parallel to the principal axis. So the rays behavior is, these rays reflects off the convex mirror and appear to diverge from the focus behind the mirror. So the image formed will be, the position will be at focus, that is behind the mirror, nature is virtual and erect, size is highly diminished. So in a convex mirror, the nature of the image is always virtual and erect. So whenever the parallel rays is incident on the mirror, it will be appears to be from focus. So the image will be formed behind the mirror and the size is highly diminished. So whenever the object is placed anywhere between infinity and principal, anywhere on the principal axis or between the infinity and pole, that is the finite distance. So if the object is placed anywhere on the principal axis or at the finite distance, what happens? So in the second case is when the object is placed anywhere on the principal axis. So what happens? The object is placed somewhere between infinity and the mirror's pole. The rays from the object reflect and appears to diverge from point. The rays from the object reflect and appear to diverge from a point behind the mirror between the pole and the focus. So here what happens, the position of the image will be between P and F and size will be very small, so the virtual and erect. So if anywhere between infinity and pole of the mirror, that is on the principal axis, what happens? So we can use any 2 rules. Okay, here the rule is when it is ray of the light is parallel to the principal axis, it appears to be coming from the focus, and if the ray of the light is when the ray of the light hit the pole, the center of the mirror, that is pole, it follows the laws of reflection of the light, that is angle of incidence is equal to angle of reflection. So when we join the reflection rays, so what happens, it will be appears to be coming behind the mirror. So the images will be formed behind the mirror, that is between principal focus and pole. The ray of light appears to be forms the images behind the mirror, that is between P and F. Size of the image is very small, nature is virtual and erect. In together we can say the object position, the convex mirror always form virtual, erect and diminished images. So the convex mirror always form virtual, erect and diminished images. So the object position at infinity means the image position will be at focus behind the mirror, and nature of the image is virtual, erect and highly diminished. So another thing, the object position is between infinity and pole, then image position will be between P and F, that is behind mirror, and it will be virtual, erect and diminished. So in convex mirror, it always forms virtual erect and diminished images. So we can see the difference between concave and convex mirror. So what about the surface? The concave mirror, the surface curved inward like the inside of the bowl or a spoon. This shape causes light rays to come together or converge after reflection. But in the case of convex mirror, the surface curves outward like the back of the spoon. This shape causes light rays to spread apart or diverge after reflection. What about the behavior of the light rays? That is converging and diverging. That means when a parallel light ray strikes the mirror, they reflect and meet at a single point called focus. But in a convex mirror, when parallel light ray strikes the mirror, they reflect and spread out as if they are coming from a point behind the mirror, which is the virtual focus. So next is image type, the real or virtual, depending upon the position of the object. But in case of convex mirror, it is always forms the virtual images. So the concave mirrors produces the real or virtual images depending on when the object is placed relative to the mirror. For example, the object is far, the image is real, inverted and smaller. If the object is close, the image can be virtual, upright and magnified. And in the convex mirror always forms virtual images. These images are always upright, smaller than the object and located behind the mirror. Concave mirror has a real focus, convex mirror has a virtual focus. So what are the uses? The focus light magnified view. And what about the convex mirror? Wide view safety purposes. So the common use is concave mirrors are used where magnified or focused images are needed. For example, shaving mirror to get a close-up image, headlights of the vehicle to focus light in a beam, telescope to gather and focus light. But in the case of the convex mirror, they are used where a wider field of view is important, such that rear wave mirrors in vehicles to see a bigger area, security mirrors in stores or on roads to monitor a wide area. So next is uses of the spherical mirrors. First is concave mirror. Concave mirrors are curved inward and converge light rays. Because of their focusing ability, they have many practical applications. Torches and car headlight. Concave mirrors are used to focus the light from the bulb into strong narrow beam. The bulb is placed at the focus of the concave mirror, so the reflected rays travel parallel in one direction. They focus light in one direction. So next is shaving or makeup mirror to magnify the image. They produce a magnified upright image when the face is close to the mirror. When the object is within the focal length, the concave mirror forms virtual enlarged and upright images. Dentist mirror. Dentists use small concave mirrors to get a magnified view of the teeth. The mirror produces a magnified and clear images of the teeth, making it easier to see details. Next is solar concentrators. Concave mirrors focus sunlight onto a small area to generate heat or energy. Sunlight rays parallel to the principal axis are focused at the mirror's focal point, heating up the spot intensely. Next is about convex mirror. Rear view mirrors. Convex mirrors are used as rear view mirrors in vehicles. They provide a wide field of view, allowing the driver to see more area behind the vehicle. So, why rear view mirrors are used in vehicles? They provide a wide field of view, allowing the driver to see more area behind the vehicle. Convex mirror diverge light rays, making the reflected image appear smaller but converging a larger area. And the other uses are security mirrors in shop. Convex mirrors are installed in shops and stores for security purposes. They provide wide angle view of area, helping shopkeepers to monitor customers and prevent theft. The curved surface allows the mirror to reflect a larger area, although images are smaller and virtual. Next is streetlight reflector. Convex mirrors are used in streetlight reflectors to spread light over a larger area. The diverging nature of convex mirror help distribute light widely, improving visibility on roads. Light from the bulb places at the center of curvature spreads out after reflecting off the convex mirror, covering a broader area. These are the uses of convex mirror. So what we have learned? In this part we learned two types of the spherical mirror, that is concave and convex. Concave mirrors curved inward and also called as converging mirror, whereas convex mirror are curved outward and also called as diverging mirror. So the reflection rules: concave mirrors focus parallel rays at the real focus, whereas convex mirror cause rays to diverge, appearing to come from a virtual focus. The image formation: the concave mirror produces real or virtual images, magnified or diminished depending on the object position, whereas convex mirror always produce virtual diminished upright images. Applications: concave mirrors are used in headlights, shaving mirror, dentist mirror, solar concentrator, whereas convex mirrors are used as rearview mirrors, security mirrors, and streetlight reflector. So what is the key difference? Concave mirror converge light, whereas convex mirror diverge light and provide a wider field of view. So thanks for watching. If you found this video helpful, please like and subscribe to our channel for more cool lessons on physics and science. See you in the next video, where we will explore the mirror formula, sign conventions, and problem solving. Stay curious and keep learning.